Hello, dear friends. Welcome to my classes. SK Booty here, Booty Aviation Training. Today, I'm going to cover an instrument called MACHMETER. And before that, I'm sure you should have read my previous lesson on airspeed indicator, in which we talked about indicated airspeed, true airspeed, etc. Just a vision. True airspeed is the actual speed of the aircraft in the air. Speed of the aircraft on ground will depend upon the wind velocity. If there are headwinds, ground distance covered is less. Tailwinds, it's more. But this true airspeed is not shown to you on the airspeed indicator. And that speed shown on ASI is known as IAS, which is proportional to density. So just a quick revision I've given you for that. If you do that lesson, it will be much better that read the airspeed indicator and then come back to this lesson on MACHMETER or MACHMETER as people call it. Mach number shown to you on the MACHMETER is a ratio of true airspeed to the local speed of sound. And when your true airspeed exceeds the local speed of sound, the airflow breaks down and it creates judder, something, the feeling of an aircraft stalling. Now, this broken down airflow could go and hit your control surfaces, etc. And if your aircraft is not designed or manufactured to withstand, your airframe is not strong enough, there could be a structural damage. So it is not at Mach 1, local speed of sound, and V being equal. Just before that, for every aircraft, there's a critical Mach number. It's that Mach number of an aircraft at which the Mach number or the airflow at some part of the aircraft, and usually that point is point of maximum thickness on the wings, the airflow has already reached the speed of sound. At critical Mach number, you feel the judder and the passengers are going to have hell of a time. They may even start praying that what is happening to us. This judder is understood by a pilot, but not by the passengers. At the moment, we have no aeroplane in civil which is doing supersonic flights. And so unless your aircraft is designed for supersonic, don't break the sound barrier. How is it possible? When you are climbing on a constant RAS, as you do in most aircraft, the density keeps decreasing, true airspeed keeps increasing. V keeps increasing. Speed of sound, C, depends on temperature. Temperature keeps dropping. C keeps dropping. With the result, your Mach number keeps increasing. And at some stage, if you are not watching your Mach meter, you could land or cross the critical Mach number. So therefore, they have provided you an instrument, all these aircraft which are capable of climbing at high speeds and high altitudes, they have given you an instrument called MACHMETER. And after a certain stage, you don't climb on constant indicated airspeed, but you fly or climb on a constant Mach number. With the help of Mach number, if you have a Rosemont probe giving you the total air temperature outside, you can find out the actual outside air temperature called SAT with this formula. In a normal slow speed aircraft, TAT, total air or RAM air temperature, is equal to still air temperature plus friction rise, whose value is V by 100 square. If V is 300, your friction rise will be 9 degrees. So total air temperature shown to you in the cockpit -9 will give you the still air temperature. For aircraft fitted with Rosemont prop, which the high-speed aircraft are, use this formula. K, when value is not given the examination, treat it as 1 or ignore it. To find out the still air temperature, actual outside air temperature, from the temperature which is shown to in the cockpit called TAT, it will be TAT divided by 1 plus 0.2 into Mach number square. If you're given in the examination, total air temperature is 3 degrees Celsius, find out the still air temperature or outside air temperature, then SAT will be equal to, and don't forget this numerical has to be done in Kelvin. Convert this to Kelvin, 276 divided by this value, 1 plus 0.2 into Mach number 0.82 square, you will get an answer of 243 Kelvin. Now convert into Celsius and answer is -30 Celsius. And this is your ambient temperature outside, also known as SAT, still air temperature, also known as OAT. This is the actual temperature. What was being shown to you in the TAT is not correct. This was your TAT. In this numerical, 3 degrees Celsius, your actual outside temperature is -30 Celsius. Now, if he says, give me the ISA deviation, then he will also give you the flight level. And ambient minus TISA at that level will give you the ISA deviation. From the ISA deviation, he may further ask you density altitude or true altitude. We have done those numericals earlier. So let's learn a little more now today about the MACHMETER. MACHMETER shows you a number. At the moment, this is reading 0.83 Mach, which is a ratio of true airspeed to the local speed of sound. Once you know the Mach number and you know the local speed of sound, you can find out the true airspeed of the aircraft, and TS is equal to M into C. In the airspeed indicator, we applied the position instrument error, density error, compressibility error, and then we got our true airspeed. Here, this is how you will get your true airspeed. Now, the formula for finding out the value of C, local speed of sound, is 38.94, or take a value of 39 into square root of ambient temperature in Kelvin, outside air temperature in Kelvin. At mean sea level, outside air temperature is +15. It will be 288 Kelvin. Now apply 288 here and you will get the speed of sound at mean sea level, 662 knots. At 11 kilometers or 36,090 feet, the temperatures become constant. You enter tropopause in ISA and the value is -56.5. So the temperature will become Kelvin 216.5, and this will be your speed of sound at 36,000 feet. So 662 minus 574, your local speed of sound falls by 88 knots in 36,000 feet, and 88 divided by 36 is roughly 2.44, or take a round off value of 2.5 knots per 1,000 feet, and that is the lapse rate of speed of sound under ISA. Let's take an example. Aircraft is flying at 20,000 feet under ISA. Temperature will be -25. In Kelvin, it will be 248. Okay. And with this 248, if you calculate speed of sound, it becomes 613 with this formula. Or second method, 662, apply the lapse rate, 2.44 into 20,000 feet. So you will get the speed of sound again. But here is a catch. Watch out. In case there is a temperature deviation, then I cannot use this lapse rate. Then the only choice left with me is find out the ambient temperature in Kelvin and then find out the value of local speed of sound. Here the same example, if there's a temperature deviation of plus 20 Celsius, then the temperature in Kelvin will be, ISA temperature was minus 25, division of plus 20, and temperature will become minus 5 Celsius. Add 273 and you will get Kelvin temperature. Your Celsius temperature under ISA was at 20,000 minus 25, but there's a deviation of plus 20. So ambient temperature will be minus 5. At 273, it becomes Kelvin. And now local of speed of sound will be 638 knots. Now, if you know the Mach number, let's say this is the example, 0.83. 0.83 into local speed of sound, you will get the two-way speed. If you are flying under ISA conditions, 0.83 into this local speed of sound will be your true-way speed. Once you know the true-way speed, apply the wind velocity and get your ground speed. So this is your wonderful instrument called MACHMETER. Mach number does not suffer from any of the normal errors of the pressure instrument, except there may be a theoretical error of instrument error. Negligible. Instruments today are made so precise under air-conditioned environment, dusty environment, that instrument error is virtually negligible. So treat this as an error-free instrument, does not suffer from density, compressibility errors, etc., with which an ASI does. So that's your introduction to the Mach number. And when you go for your Boeing conversion, Airbus conversion, and he talks about Mach number and you'll be flying at this Mach number, don't be surprised. Tell him you are already educated. Fine, he'll be happy that you know these things. And time to sign off now, stop here. But before you log out, would you take a few seconds, spare a few seconds and like this video? And as also subscribe to the channel if you haven't done, and press the bell icon for notifications. And most of all, how about sharing it with your friends also? Okay, good luck, all the best, and hoping to see you with me again and again and again. And SK Booty signing off for the day. Will be coming up with many more lessons at regular intervals. Okay, bye-bye for the time being.